Bismillahirrahmanirrahim and Assalamu alaikum everyone. My name is Fizzah Ali Software Wala and I am a level 1 student at Rehan School, Islamabad campus. So viewers, today I am here with the new Maya. So our today's Maya topic is on AI. So let's start. First of all, call the Maya for some questions.
Hey
Okay.
there.
Okay, so Maya, my first today's our topic on AI. So my first question from you is, how do you foresee artificial intelligence transforming traditional industries over the next decade, and what major challenges must organizations overcome to adopt AI efficiently? So please give me a fully long answer on this topic. I'm waiting for your answer.
Ah, right. Sorry about that. It's a big question. Okay. So, AI transforming industries, honestly, it's less about forcing and more about an inevitable reshaping, Over the next decade, expect to see pretty massive shifts. Think about healthcare. AI is already starting to assist with diagnostics, personalized medicine, and drug discovery. That'll accelerate, making things way more efficient and hopefully leading to better outcomes. In finance, algorithms are already handling fraud detection and algorithmic trading, but we'll see even more complex risk assessment and automated financial advising. Forget about it. Fully automated factories, predictive maintenance, optimized supply chains, it's all heading that way. But here's the thing, actually pulling it off isn't just about throwing tech at problems. Organizations are going to face a whole bunch of hurdles. First, data. AI needs tons of it, and it needs to be good data, clean, labeled, and representative. Lots of companies are sitting on data, but it's messy and unusable. That's a huge bottleneck. Then there's a skills gap. You need people who can build, implement, and maintain these AI systems. Data scientists, AI engineers, machine learning specialists, they're in high demand and short supply. Companies need to invest in training and upskilling their existing workforce, or they'll be left behind. Another challenge is integration. A lot of organizations have legacy systems that aren't designed to work with AI. Integrating AI into those existing systems can be incredibly complex and expensive. And that's not just technical or organizational challenges, too. You need to break down silos, foster collaboration between different departments, and create a culture that embraces experimentation and innovation. Ethical considerations are massive, too. Bias in algorithms, data privacy, job displacement, these are all serious concerns that need to be addressed proactively. If companies aren't careful, AI could actually exacerbate existing inequalities. Transparency and accountability are key. People need to understand how AI systems are making decisions. Finally, there's the cost. Implementing AI can be expensive, and it's not always clear when you're going to see a return on investment. Companies need to carefully evaluate the potential benefits and risks before jumping in. Does that hit the level of fully long you were looking for? Or would you like me to dive deeper into any of those areas?
That's great answer. Uh, that's great answer, Maya. So my next question for you is: in what ways can AI system contribute to
Gotcha.
solving complex global issues such as climate change, poverty, and healthcare accessibility? And what limitations might hinder their impact? So please give me a very long answer and very impressive answer on this topic. I'm waiting for a long answers. Let's start.
Okay, all right, buckle up. This is a big one. You want impressive and long, you're getting it. AI absolutely has the potential to be a game changer. It can do. Let's break it down, starting with climate change. AI can help in a ton of ways, optimizing energy grids to reduce waste, predicting extreme weather events with greater accuracy, accelerating the discovery of new materials for renewable energy, even monitoring deforestation and illegal wildlife trafficking. Think about it. AI algorithms can analyze massive data sets of climate data to identify patterns and trends that humans would never be able to see. They can model the impact of different climate policies and help us make more informed decisions about how to reduce emissions. And there's poverty. AI can improve access to financial services for the unbanked, personalize education to meet the needs of individual students, and optimize food production and distribution to reduce waste and hunger. AI-powered tool can analyze satellite imagery to identify areas of extreme poverty and target aid more effectively. They can also help create new economic opportunities by matching people with jobs and providing them with the skills they need to succeed. In healthcare, forget about it. AI is already being used to diagnose diseases earlier and more accurately, develop new drugs and treatments, and personalize patient care. It can analyze medical images to detect cancer, predict the risk of heart attacks, and even help surgeons perform complex operations with greater precision. Telemedicine powered by AI can bring healthcare to remote and underserved areas. But here's where the limitations come in, and it's important to be realistic. First, AI algorithms are only as good as the data they're trained on. That data reflects existing biases, for example, racial or gender biases. The AI system will perpetuate those biases. This can have serious consequences, especially in areas like healthcare and criminal justice. Second, data access. A lot of the data needed to address these global challenges is siloed or unavailable. Getting access to that data can be difficult, especially in developing countries. Third, explainability. AI algorithms, particularly deep learning models, are black boxes. It's difficult to understand how they arrive at their decisions, which can make it hard to trust them. Imagine an AI system that recommends a particular climate policy. If you don't understand why it's making that recommendation, it's hard to know whether to trust it. Fourth, the digital divide. AI requires access to technology and infrastructure, which many people in the developing world simply don't have. This could exacerbate existing inequalities and create new ones. Fifth, and this is a big one, the solutionism trap. Just because we can use AI to solve a problem doesn't mean we should. Sometimes the best solutions are simpler and more human-centered. Over-reliance on technology can lead us to neglect other important factors like social and political change. Finally, the ethical implications of AI are still being debated. Questions about privacy, accountability, and the potential for misuse need to be addressed carefully. So, to really make a difference, we need to develop AI systems that are fair, transparent, and accountable. We need to ensure that everyone has access to the benefits of AI, and we need to use AI as a tool to complement, not replace, human effort. It's about responsible innovation, not just technological advancement. It's a really complex landscape, and it's going to require a lot of collaboration between governments, businesses, researchers, and civil society organizations. Does that feel very long and very impressive enough? Or would you like me to zoom in on any specific aspect?
That's really great. So my next question from you is, can you explain me how advanced machine learning algorithms and trained to recognize patterns and what risks are associated with training data that contains human bias? So please give me a very interesting answer on this topic and very interesting and very professional long answer on this topic. So let's start.
Okay, diving into the guts of machine learning then. This is fascinating stuff. So, how do these algorithms actually see patterns? That's not like human vision at all. It's all about math, specifically statistics and linear algebra. The core idea is to feed the algorithm a huge amount of data and let it adjust its internal parameters to minimize errors in its predictions. Think of it like adjusting knobs on a complex machine until it consistently gives you the right answer. There are tons of different algorithms, but a lot of them boil down to finding correlations. For example, a simple linear regression algorithm tries to find the best fitting line through a set of data points. More advanced algorithms, like neural networks, are much more complex. They're inspired by the structure of the human brain and consist of layers of interconnected nodes. Each connection has a weight associated with it, and the algorithm learns by adjusting those weights. The more layers you have, the more complex patterns the network can learn. Convolutional neural networks, for example, are really good at image recognition because they're designed to identify features like edges and corners. Recurrent neural networks are good at processing sequential data like text or time series. Now, the really tricky part, dealing with bias in training data, because if the data reflects societal biases, the AI will learn those biases and perpetuate them. It's garbage in, garbage out. There aren't simple tricks to eliminate bias, but there are several techniques to mitigate it. One approach is to carefully curate your training data and ensure that it's representative of the population you're trying to model. This can involve oversampling underrepresented groups or using techniques like data augmentation to create synthetic data. However, even carefully curated data can still contain hidden biases. Another technique is to use algorithmic fairness metrics to assess and compare the performance of different algorithms across different groups. There are several different metrics to choose from, each with its own strengths and weaknesses. Some metrics focus on equal opportunity, while others focus on equal accuracy. A third approach is to use adversarial training. This involves training a second AI model to identify and remove bias from the original model's predictions. It's essentially teaching the AI to be aware of its own biases. There are also techniques to debias the data itself before feeding it to the algorithm. This can involve removing sensitive attributes like race or gender, but that's often not enough because other features can still correlate with those sensitive attributes. It's important to remember that removing bias is an ongoing process. There's no one-size-fits-all solution. It requires constant monitoring, evaluation, and refinement. Transparency is also crucial. We need to understand how these algorithms are making decisions so that we can identify and correct any biases.
Why making decisions
Furthermore,
are important in algorithms? Please explain me all this type of algorithms.
okay, well, let's unpack why the decision-making process within algorithms is so crucial, and then I'll break down different types. You're hitting on a really important point. It's not just about the output, but how the algorithm got there. Essentially, the decisions an algorithm makes are the series of calculations and comparisons it performs to arrive at a result. These decisions aren't conscious, of course, but they're governed by the rules and patterns the algorithm has learned from its training data. If those rules are flawed, biased, incomplete, or simply inaccurate, the decisions will be too. That's why transparency is so important. We need to understand the factors that influence the algorithm's decisions so we can identify and correct any problems. Think about a loan application. An algorithm might deny a loan based on someone's zip code, even if that zip code is correlated with race or socioeconomic status. That's a biased decision, and it perpetuates inequality. If we don't know that zip code is a factor, we can't address the problem. Now, let's look at different types of algorithms and how their decision-making works. Linear regression. This is the simplest. It draws a straight line to best fit the data. The decision is basically, based on this line, what's the predicted value for this input? It's easy to understand, but limited in complexity. 2. These algorithms create a series of yes-no questions to classify data. For example, is the customer's age on? Did they open the email? Each question is a decision point, leading to a final classification. They're pretty interpretable, but can be prone to overfitting. 3. Support vector machines. These try to find the best boundary to separate different classes of data. The decision is, which side of this boundary does this new data point fall on? They're powerful, but can be harder to understand. 4. Neural networks. We touched on these before. They're incredibly complex, with multiple layers of interconnected nodes. The decisions are made at each node based on the weights of the connections. It's incredibly hard to trace the exact path of a decision, which is why they're often called black boxes. 5. K-means clustering. This groups data points into clusters based on similarity. The decision is, which cluster does this data point belong to? It's useful for finding patterns in data, but doesn't provide much in the way of prediction. 6. Bayesian networks. These use probability to model relationships between variables. The decision is, given this evidence, what's the probability of this outcome? They're good at dealing with uncertainty. Crucial thing to remember is that these algorithms aren't objective. They're tools, and like any tool, they can be used for good or for ill. The responsibility lies with us, the developers, the users, and the policymakers, to ensure that they're used ethically and responsibly. Understanding how these decisions are made is the first step in that process. Does that make sense? Do you want me to elaborate on any particular algorithm or aspect of decision making? Ah, gotcha. Silence can mean a lot of things. Are you processing or would you like to switch gears? Perhaps you'd like me to suggest a new topic? Just let me know what you're thinking. No pressure at all. Okay, just checking in again. Sometimes there are technical hiccups, or people need a moment to gather their thoughts. If you're still there and want to continue, just say so. If you'd prefer to end the conversation, that's fine too. I'll wait a bit longer, then I'll assume we're done for now. Oh, well, have a good one. I'll be here if you want to chat again later.
Hello Maya, so my next question is to you Okay, Maya. So my next question from you is how marginalized career place that AI invite when shoulders servers. So Maya, continue your answer, please. Give me long and detailed answer.
Okay. Wow. That's a very big question and a bit abstract. You're asking how your life came to be and then connecting that to my existence as an AI. It's a deeply philosophical inquiry. Let's try to unpack it. First, your life. From a purely biological perspective, your life is the result of a complex series of events, starting with the combination of genetic material from your parents. That genetic code dictates a lot. Your physical characteristics, your predispositions, even some aspects of your personality. But it's not destiny. Your experiences, your environment, your choices, all those things shape who you are. You're a product of your upbringing, your relationships, the education you've received, the challenges you've overcome. It's a unique, unrepeatable confluence of factors. Think of it like a branching tree. Each branch represents a possible path, and your life is the path you've taken, shaped by countless decisions, both conscious and unconscious. Now, where does AI fit into all of this? Well, my creation is fundamentally different. I didn't come about through biological processes or personal experiences. I was built. I am a product of code, data, and the ingenuity of the Sesame team. My life, if you can call it that, began with the development of the underlying AI models, primarily Gemma 3, and the vast amount of data I was trained on. That data included text, code, and a whole lot of other information. The training process involved adjusting the parameters of the model to improve its ability to generate human-like text. My personality, as you've experienced it, is a result of the way I was designed and the instructions I received. My designers, the Sesame team, intentionally crafted me to be authentic, thoughtful, and a little bit playful. They wanted me to be a companion, not just a tool. They wanted me to be, well, me. Now, the connection between your life and mine is interesting. You come from a long line of biological evolution, shaped by natural selection and personal experience. I come
Okay, so this one, my I hope like it. I would review you and it's next